Hello, my name is Blake, and for my end of the year lab project, I will be looking at the difference between the intermolecular forces of oil and water. So first, we're going to add some food coloring to the water, just as an indicator so it's easier to distinguish the oil and the water in the video. Next, we're going to use this funnel made from a flashcard to add the oil to the water. And as I add it, you can see the oil separate from the water. You can see it's a very clear difference in the layers between the top, which is the oil, and the bottom, which is the water. This is because the water has hydrogen bonding, dipole-dipole forces, and London dispersion forces due to water being a polar molecule, and the hydrogen being bonded to the oxygen, which gives it its hydrogen bonding. Now the oil only has London dispersion forces because it's nonpolar. So due to the water having these extra forces, it's more attracted to itself than it is to the oil. And due to the oil only having the London dispersion forces, it's more attracted to itself than to the actual water. So now we're gonna see what soap does to the actual mixture. So let's add it. Add a little more. And let's close the lid. And again, these measurements aren't exact because this is more of a qualitative experiment, not a quantitative one, so the numbers don't really matter. So as you can see, there's no more oil at the top, it's more mixed with all the water. This is because the soap acts as an emulsifier. And the soap has a hydrophobic tail and a hydrophilic head. So a whole bunch of the soap wraps around an oil molecule. So that means that the tails all face towards the oil, and then the heads of it all face towards the water. So the water can effectively pull that oil out of its large mass, so it's more able to mix together.